man squatting on the ground and gets straight up and stand. Okay, the force of reaction of ground on the man during this processes. So now they are asking us about the force of reaction by the ground on the man. So in order to understand that, let us first understand what is happening in this whole process of getting up from the squatting position. So what happens over here is, when the man was in squatting position, his shoes apply variable force on the ground. Okay, his shoes apply variable force on the ground. Okay, here the force was larger. Let us indicate with larger arrow so that it will be easy. So as the man, so now when the man was in the squatting position, his shoes apply variable force on the ground. That is action force on the ground. Okay, it is the action force acted upon the ground by the man. So here you can see that when the man is in this process of getting up from the squatting position, the man applies variable force because he applies here the larger force to get up. When he is in this position, then he applies this force which is less than this larger force. Okay. So when he is in this position, then that force which he is applying through his shoes on the ground is also less than the previous one. And finally, when he stood up on the ground, then the force which is equals to mg, the force acted by the man by his shoes on the ground is equals to mg, which is equals to its weight. Okay, his weight. So the amount of force exerted by his shoes on the ground in the final position when he stood up, the force exerted by his shoes on the ground is equals to mg. So in the overall motion, now this was the action force exerted by the this was the action force by man on the ground. Now they are asking us to identify the reaction force. Reaction force. We know that according to Newton's third law, every action has a reaction, and both the magnitudes of the action reaction forces are equal, but they are opposite in direction and they are acting on the different bodies. So this was the action force was acting on the ground. Now the ground in return of this, ground will also apply the same amount of force on the man. So when he acted some force on the ground, then ground will also apply the same amount of force on the man. That is called reaction force. Okay. So let us indicate with different colors so that it would be easy for you people to understand. So this was, so reaction force was exerted by the ground. Okay. So here the say when this man was acted with some force FL, then the reaction force was also acted on the man. This reaction force, now the reaction force is by ground on the man. So the by ground on man. So here you can see that the reaction force which is acting on the man is also varying, because the action force which was applied by the man was variable force. So in return of that, the ground will also apply the same amount of force but in the opposite direction on the different body. So that will be also variable force. So reaction force, what we conclude is the reaction force applied by the ground on the man is a variable force. Okay, is a variable force. And finally, when the man stood up in the standing position, then during that time the force exerted by by the shoes on the ground was mg. Then the reaction force, that is the force exerted by the ground on the man shoes will also be equals to mg. So what we conclude, the reaction force is variable force, and that at firstly in the previous cases, before standing up, firstly the force which is applied, which is the force reaction force or the action force, both are greater than mg, and finally it becomes equals to mg. So our option A is wrong because they say that the reaction force is constant, which is wrong. Okay, here they say that it is constant and greater than magnitude in mg, so it is also wrong. Coming to option C, you may think that it is true, that it is also wrong, because they are saying that the reaction force of the ground on the man during this process is variable force but always greater than mg. It is not true, because we have seen that the reaction force is not always greater than mg. at the final instant, when the man stood up, when the man attains his standing position, then during that time the reaction force by the ground on the man becomes equals to mg, that is not greater than mg always. So our option C is wrong. Coming to option D says that at first the reaction force was greater than mg and later it becomes equals to the mg is true. So option D is